Okay, cool. Let me tell you a story. This last year, I expect it's been difficult for people to travel, but maybe some of you have been to Italy before. I hope you do. I'm originally from over there, from Verona, up in the north. But I expect that not many people know about this place in Italy called L'Aquila. L'Aquila is one of those hidden gems of Italy. He has this lovely, beautiful castle towering on top of the city, on the hill, looking down. And of course, being Italy, you can eat some amazing food. They make these really typical lamb skewers that they call arrosticini, and served with this typical glass of red Montepulciano wine. Unfortunately, L'Aquila, as I've just described it, doesn't exist anymore. And the end of it all started on the 14th of December 2008, 13 years ago. It was a quiet Sunday morning, cold Italian Sunday morning, when most Italian families are busy preparing their Sunday lunch. And all of a sudden, the ground starts shaking. It was an earthquake, a small one, just under magnitude 3, but it was enough to make everyone scared and run out of their homes into the streets. Little did they know at that point that that was only the first of many dozens of earthquakes that over the following months led to the 6th of April 2009, when right in the middle of the night, 3:32 a.m. in the morning, an earthquake of magnitude 6.3 hit the city, completely destroying it. 309 people died that night, many more were wounded, and damages were estimated for around 10 billion euros. It's a complete tragedy, but I'm telling you this story because there were two interesting facts that happened around this earthquake that make for a good metaphor for some of the lessons I want to share in this talk. The first interesting fact is that just the day after the earthquake hit, this guy, pretending to be an expert, went to the media and claimed that he had predicted it and that he had tried to raise the alarm, but that the authorities had forbidden him from doing that. Later on, this turned out to all be false. It was all a constructed story. But the media picked up on it and turned this guy into a hero, saying that if only we had listened to him, we could have saved so many lives. So the first interesting fact, this fake expert gets treated as a hero. Second fact, in the months before the final earthquake, the Italian government actually put together a bunch of scientists and experts and asked them to look into the possibility that a stronger earthquake was going to happen. And these experts came back to the government saying, you know what, for this area, this could be considered normal, but there is also a small chance that these are the signs of a bigger earthquake that might happen soon. The government only heard the first part, that this could be considered normal, and decided to do nothing about it. And of course, then the earthquake actually happened. But the interesting fact is that after the earthquake, these scientists were put on trial with the accusation of having failed to predict the earthquake. So second fact, the actual experts that explained the possibilities were treated as criminals. When we talk about earthquakes, it's very common to ask the question, can earthquakes actually be predicted? And seismology is very clear. The answer is no. With today's knowledge, we cannot predict earthquakes. If by predicting, we mean knowing when they're going to hit, when and with what intensity. We can't make these sort of deterministic predictions. We can, however, quite easily forecast earthquakes. It turns out that they follow some quite stable statistical patterns. For example, in the region around L'Aquila, they knew from historical data that they get an earthquake of magnitude at least 6, so magnitude 6 or over. They get one like that around every 300 years. They had one in the 1400s, one in the 1700s, and one in 2009. So at L'Aquila, they knew that in the next 20 to 50 years, there was a really high chance of a strong earthquake to happen. But unfortunately, they did nothing with that information. And I thought these were some interesting metaphors for the two key lessons that I want to share with you today in this talk. One is that when we're dealing with uncertain events like earthquakes or software projects, a forecast will almost always beat an estimate. We need to start to think more probabilistically in terms of what can and can't happen, because an earthquake might happen in our projects. But to be listened to be treated like the heroes and not like the actual experts that get put on trial, we need really good communication. We need to learn how to explain what can happen in our projects and how to communicate risks and options. And over the course of this talk, I'll show you a few examples of how I do this with my teams. I'm Mattia Battiston. I'm originally from Verona, but I've now lived in London for 7 or 8 years. I'm an engineering manager currently at Bulb. We're an energy company. Before I was at other companies where some of these examples are from. And if you like what I'm talking about today, I recently co-authored this book, The Team Guide to Metrics for Business Decisions, which you can get with a 20% discount from Leanpub if you like an electronic version, or it's also available in print from Amazon and a few other places. I do have a couple of copies on me to give away, so if you come and talk to me, I can give you one. First in, first out. At some point, I expect most of our teams, most of your teams, will have had to answer questions like this. How long is this piece of work going to take? Can we complete this piece of work by this particular date? What can we do in this period of time? These are very legitimate business questions that we all get on a regular basis. And our answer in Agile teams is typically using a tool like story points or any sort of estimation technique that relies on giving our best guess. This is data that I took from one of the teams I was working with, and at the bottom here it shows the number of story points. Each blue dot here is a user story. And on the vertical axis we got the lead time of stories, so how long a story actually took from start to end. What this data showed to me and my team is that stories of 1 point in this team were taking from 2 days to 10 days. Stories of 2 points were taken from 2 days to 20 days. Stories of 3 points from 6 to 18 days. There was very low correlation between our estimates in story points and how long things were actually taking. And this came as a surprise back then, but it's actually very, very common. More and more teams in our industry are finding very similar results. And if you're curious to try with your own team, we publish some free spreadsheets you can use. You plug in your data and you can see if the same is happening inside your team. But this low correlation is very, very common. And there are typically 3 reasons why our estimates are so often not correlated to how long things take. The first one, which is really, really common, is that in our teams we have too much work in progress. This is a great analogy I stole from Troy McGuinness, which is one of the top experts in this area. In a road like this, when it's so busy, it doesn't matter what size you are. It doesn't matter if you're a scooter, a car, or a truck. You all move at the same speed, very, very slowly. Similarly, in our processes, when we have so much work in progress that it feels like this road, each story moves at the same speed. Each story moves very, very slowly because we are so busy. And at that point, the size of the story stops mattering, so it doesn't matter anymore. The second reason why our estimates are so often wrong is that in our processes, it's very, very common to have queues. This is just an example process, what might be a Kanban board of a team. But it's very common to have some states, I don't know if you can see the colors properly, but some states that are showed in green here where you're actually working on something when you're adding value to a piece of work. And other states where work is just waiting for something to happen. Maybe it's waiting for a developer to become free, waiting for a test environment to be available, for all sorts of reasons. It turns out that if you look at the percentage of time that work spends in this red state, in the queue state, compared to the green state, we call this metric flow efficiency, by the way. That percentage of time is the percentage of time that work spends in value-adding state is as low as 15%, quite typically. So only 5 to 15% of the time is spent actually working on something, and the rest of the time work is sitting, waiting for something to happen. And when we are asked for an estimate, our brain immediately thinks about how long will I have to work on something. So we're only taking into account the actual green time rather than how long it's going to take for something to go from start to end. And the third reason is that, of course, there are many unexpected events that happen over the course of our projects. There are blockers, bugs, pandemics, and at that point, your estimates just go out the window. So more and more teams in our industry, more and more companies are realizing this and are getting to the conclusion that the only size that matters for a piece of work is small enough. Nowadays, I coach my teams on doing story breakdown, story slicing, and so long as we make an effort to break things as small as possible, then the size of the work doesn't matter anymore. We don't bother putting a number on each story. We just rely on that and use historical data and some metrics that I'm about to show you. I'm going to preempt some of the common questions I get, like what data do I need and what tools can I use? This might come as a surprise, but you actually don't need much data at all to get started. Everything I'm going to show you in this particular presentation, you can get with just getting the start and end dates of a story. So long as you're recording or extracting from your tool when a story starts and ends, that's all you need to do everything that I'm showing you in this talk. And 5 to 11 samples are plenty to get some decent accuracy. With 5 samples, you're already in the right ballpark. 7 or 8, you start to have good accuracy. From 11, you're pretty much set. That's all you need as a minimum to do a lot. Of course, if you can capture some other data that will help you later on to interpret your data and metrics. But if you just keep track of start and end dates, then you can do a lot. And they should be fairly easy to extract from whatever tool you're using. Speaking of tools, this might sound weird at a technology conference, but I still do recommend starting with some spreadsheets. We published some with our book. Troy McGinnis has a whole bunch of free spreadsheets that you can download. I recommend starting with a spreadsheet because you get that flexibility to analyze your data, segment it in a different way, and play around. And after a while, once you know what you're looking for, you know what you're doing, there are some tools that are pretty decent nowadays that integrate with some of the other tools you might be using and can do a lot for you. But let's get into some of the actual metrics that we use in my teams and how we use them. The first one I want to talk about is called lead time. You probably heard of it. Some people call it cycle time. I'm not really precious about what you call it, so long as we all understand what we mean. And what I mean by lead time is how long something takes from start to end, which sounds like a simple definition, but the tricky part is agreeing on what the start and end is. This is just an example Kanban board from one of the teams I worked with. This team was using Kanban. This is their actual Kanban board. So for this team, the start was this first column, which in Kanban you call the commitment point. These were our work in progress limits of 2. So whenever we pulled in the next story, that was the start of the lead time for us. In a more Scrum-like process, maybe your start would be when you're actually starting to work on a piece of work, whenever it moves to in progress or something like that. The end, again, can vary. This is just an example, but so long as you know what your definition of done is and when you consider a story to be done, that's when your lead time stops. In this particular example, this team had two different types of work, one that could be released immediately, one that had to wait for a bit longer, so we had two different definitions of lead time, but that doesn't matter too much. I'm just trying to stress that you need to have a clear definition of what you mean by the start and end points of your process. And once you have that, you calculate your lead time, you can generate this really useful metric called lead time distribution. This is one I use all the time, and here is how it works. It's basically a histogram. What we're doing here at the bottom, we've got all the possible lead times in days that happened in the past, and on the vertical axis, we're just counting how many stories have taken that long in the past. So this team had 7 stories that took 1 day, 8 stories that took 2 days, 3 stories that took 3 days, and so on. It's quite typical to find that this sort of shape, left skewed, but that doesn't matter too much. I like to put my data in this table here to explain how I use it. So because I know how many stories have taken how long, I can express that as a percentage. So I know that in this team in the past, 13% of the stories have taken 1 day, 15% of the stories have taken 2 days, and so on. Now, if you sum them up cumulatively, you find out that 52% of the stories in this team have taken 4 days or less, and 88% of the stories have taken 9 days or less. And using this data, we can have some really, really interesting conversations. Here is an example. These are actual conversations that I have on a regular basis with my stakeholders, my product managers, whoever wants work from the team, or sometimes even the team itself. How long will this story take? Someone wants a story done, and they're asking us when will they get it. Here is how I answer. I go back to that data I was showing you. I use this table, and I look at this line highlighted with the red circle. This is the first line where this color, if you can see, it turns green. I use the color coding of green to represent where I feel that I have a high confidence in my result. This is the first line in my data where I have over 80% confidence. So I know that 88% of the stories in the past have taken 9 days or less. And so my answer is something like this. We are 80% confident that it won't take longer than 9 days. There is a chance it might take just 4 days. So, if we're lucky, we might get your work done in just 4 days. But bear in mind, there's only a 50% chance. So I'm not going to make a strong promise on that. By the way, in the worst case scenario, we might need 10 days to complete this piece of work. We know there's only a small chance, it's only 10%, but there is a chance that this might happen. And this is when the conversation becomes really interesting, because we can ask, what would be the impact if the work ended up actually taking 10 days? Would it still be valuable? What is the value of this story if it takes more than 4 days, more than 9 days, more than 10 days? So all of a sudden, we're changing the conversation from estimates and planning to the value of the piece of work and how valuable it is depending on when it might be ready. Another real-life example. This was in a company in the broadband domain. So we were releasing software to do with customer service. For all sorts of legacy reasons, this software was only released on a monthly basis. And we had our next release scheduled in 4 days' time. And the managers of the call center came to us asking for an extra feature, a new piece of work that was going to help them. And they asked us this question. The next scheduled release is in 4 days. They wanted this particular piece of work done, and they wanted to know, will this story be ready in time? Because if it's going to be ready, I need to train the people in the call center on how to use this feature. We might need to change some of the scripts we use to talk to our customers. So we looked at our data again, and the data is telling me that in the past, only roughly 50% of the time we completed something in 4 days. And so that's what we told them. We're only 50% confident that we can make it in time for this particular release. What do you want to do? Do you want to risk it or not? Should we go ahead or not? At which point they decided that they were going to wait for the next release. The cost of training people for something that might not happen was too high for them. They would have needed to repeat the training later on, and it would have led to confusion. So the team, in the meantime, started working on it anyway, but it was hidden behind a feature flag, and we knew we weren't going to release it anyway. And it made the next release. Another metric I use all the time is throughput, which a lot of teams might call delivery rate or story count, because it's literally just that. It's literally just the count of how many stories, how many work items you get done in a particular period of time. The most common period of time that people use is the sprint, or a period of a week or 2 weeks, or whatever you're using. So I'm literally counting how many stories get done in each sprint. So this team completed 11 stories in sprint 1, 9 stories in sprint 6, and so on. You're just counting how many things get done in a particular sprint. And using that, we can calculate some useful statistics, but without getting too much into the maths, I'll show you some practical examples of how I use this data. And yeah, once again, we've got some spreadsheets you can use if you want to plug in your own data and see what happens. This is how I use throughput to answer something like this. How many stories can we complete in the next sprint? Maybe this is a question you might get during sprint planning, or maybe even if you're using something more like Kanban, maybe you're just asking yourself, how much work can we complete in the next 2 weeks? Because it's still a useful piece of information. I look back at my stats on the throughput, and I look at these 2 lines that I've highlighted with the red circle. This bottom one is telling me that in the past, this team completed at least 5 stories in 80% of their sprints. So in most of their sprints, they've completed at least 5 stories. And 50% of the time, so half the sprints, they get up to 8 stories. And so that's the sort of conversation that we have. We are 80% confident that we can complete at least 5 stories. We might get up to 8, but there's only a 50% chance. So we could make a strong commitment on those first 5 stories and put a maybe with a little star on the remaining 3 stories. And a great way to visualize this, which I use a lot, is this technique called rolling wave forecasting. Assuming that you have a prioritized backlog somewhere, next to the backlog, I visualize how confident we are that the team will complete that particular story in the next 2 weeks. So we have high confidence that the top 3 stories will definitely be delivered, 50 to 80% confidence of the following 3 stories, under 50% on the next 2, and so on. I share this with my stakeholders, and in real time, they can reorganize the priority of the backlog based on how confident they need to feel that a particular piece of work is going to be ready in the next 2 weeks. Another example I love, a situation like this, my product owner or manager or whoever is having this conversation with you, someone wants our team to complete 10 stories in the next sprint. They're telling us to go faster, or maybe there's a deadline or pressure to deliver this amount of work somehow. And they're asking us, can you do it? Can you get this much done in the next sprint? I look back at the data, and the data is telling me that in the past, only 25% of the times we completed up to 10 stories. So usually we complete less than 10. And that's my answer. We only have 25% confidence that we can complete the 10 stories that you asked for. Are you willing to take such a high risk? most importantly, I love this second question, what is the impact of being wrong? What if we say yes to your 10 stories and then we can't make it? What is the impact to the business? What is the impact to the stakeholders? What happens? And this leads to really useful discussion about business value again and the impact of the work rather than estimates and plans. I also want to point out how, teams mean well. Teams want to do a good job, and maybe someone is, asking this with good intentions. That they're asking us, can you complete this piece of work? Because maybe this is going to help some customers or help some of our users. It's very easy for a team to feel under pressure in this situation to say yes and just say, yeah, okay, we're going to try. And then they end up cutting corners, working overtime, working late, but because of that pressure of wanting to get the job done, to say yes. But using data instead, it doesn't completely remove that pressure, it doesn't completely remove that risk, but it helps us stay more objective. It helps us say, well, we want to try, but there's only a 25% chance that we can do it. So we looked at how long a single piece of work is going to take. We looked at what can I get done in a single sprint. What about bigger pieces of work? What if we're talking about a larger feature or a project, something that is multiple stories, multiple epics, something that doesn't fit into a single sprint? So we're talking, I'm going to use the word project, but I mean something bigger than a single piece of work. How long will this project take? How would we answer that question? This is where we really struggle as teams. This is where we still struggle in Agile teams. I use this technique called probabilistic forecasting, which is a really fancy name for a spreadsheet. The idea is to use your historical data to simulate and predict what's going to happen in the future in the same way that we've just done. And then you express the result as a list of possible outcomes with the probability that that particular outcome might happen. Sounds really fancy. In practice, it's a lot simpler. Here is how it works step by step. What we need two pieces of information in input. On the right, I put in input the past throughput of the team. So this is the data we just looked at on the throughput. And I know that in this team, they completed 2 stories in sprint 1, 5 stories in sprint 2, 4 stories in sprint 3, and so on. This is how many stories they've completed in past sprints. And on the left here, we've got the amount of work that we're trying to forecast. So someone came to us with this requirement, this project that they want us to do, and doing some workshops or spikes or whatever, the team somehow identified that we have about 25%, the team broke down the work into 25 stories that they think they need to complete to achieve this project. So that's the number 25, that's the amount of work that we expect to do. We also need to take into account that over the course of this project, there's going to be some bugs, and this is based on historical data. This team encountered a bug every roughly 10 stories. But also we need to take into account that we're going to discover things. We're going to realize that one of the 25 stories we initially broke down actually was too big, and we need to split it into smaller things. Or we'll just realize that there are some extra things we didn't think about. This is really, really normal. And again, looking at historical data, looking at how the backlog grew in the past, this team knows that they more or less find a new story every other 5 stories. So with this data in input, we run what we call a Monte Carlo simulation, which is a lot simpler than it sounds. Here's how it works. In this example, the team is trying to forecast how long it's going to take them to complete 20 stories. So what we do, I'm going to go back a slide, sorry. We look into our throughput that the team had in the past, and we pick a random sample from here. we pick at random one of these samples. And so in this example, we pick the number 3. This is us pretending that in the first sprint, the team will have completed 3 stories. Therefore, they will have 17 stories remaining to do after the first sprint. Then you do it again. This time we pick the number 5. So we're simulating that after 2 sprints, the team will have completed a total of 8 stories. Therefore, there will be 12 stories remaining. You keep going until after 5 sprints, the team has completed 21 stories, meaning that they have completed the whole scope, the whole backlog of work that they wanted to complete for this project. So in this first simulation, the answer is 5. It took 5 sprints to complete this project. Now, the Monte Carlo trick is simply to repeat this simulation a few thousand times. You do it in a spreadsheet, you repeat, 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 and sometimes you'll be lucky and have simulations where it only takes 4 sprints. Sometimes you are very unlucky and you have simulations where the team took 7 sprints. But in repeating it so much, you get a lot of statistical variation and all the possible outcomes that can happen. And then with a bit of analysis, you express your results with some probabilities. We know that 37% of the simulations told us that the team is going to take 4 sprints, and 31% of the simulations took 5 sprints. So similarly to earlier, we can tell that in 85% of the simulations, the team took 5 sprints or less. So they were done after a maximum of 5 sprints. So the conversation goes something like this for me. We have about 50% chance of completing the work in 4 sprints, but we are very confident, we are 85% confident that it won't take longer than 5. So the project is going to land somewhere between 4 and 5 sprints. Bear in mind that in the worst case scenario, we might need 6 sprints. We know that there is a chance that it might take 6 sprints. And what would be the impact if that happened? So again, we go back to talking about the business impact of the work. Will this project still be valuable if it ended up taking 6 sprints? Can we find maybe an MVP that we can release earlier to try and minimize that risk? And then we add this last piece that is maybe my favorite. We're actually going to review our forecast after each sprint. And this is where we enter something called continuous forecasting. Now, this slide is a bit busy, but let me explain what's happening. This is an example from a real project, again, that we were doing in the broadband domain. It was about November time, and someone approaches the team with this project, which was a new piece of regulation. Ofcom wanted this new regulation done, and we needed to comply by the end of March, otherwise we would have got this big fine, which was costing us a lot. So we had to do this project by March time, and it was November time when we were approaching, when the team was approached. So this is at the beginning of the project. The team identified 10 stories that they needed to implement for that project. Here we were running that Monte Carlo simulation I was showing you, which gave us the result that we were pretty confident we could get those 10 stories done in 5 sprints. We were currently in an iteration, in a sprint that we were calling 3-3-3. So 5 sprints time meant that the project was going to be done in a sprint called 3-3-8. And we were visualizing that with this burn-up chart where the top line is our backlog, and in the yellow line is our optimistic forecast, which we had low confidence in. So it could take just 3-4 sprints, but we have low confidence in that. And the green line was the forecast with a high level of confidence instead, that showed us that the 5 sprints it was going to take. So the team sets off. Here's what happened after the first sprint. You notice what happened here? The team actually completed the first 3 stories from the backlog, but the size of the backlog had actually gone up instead of down. And instead of the number of stories, instead of going down, had gone up to 13 now. And our forecast was now telling us that we were going to complete those 13 stories in a sprint called 340. So a bit farther down the line than we initially expected. It was now projected towards end of February, still in time to meet the regulation, but we needed to be careful now. And that work that we identified, by the way, the extra work was, just things that you discover along the way, the sort of things that happen in software projects. Some things were more complex than we expected. Some requirements had been missed because when you're dealing with regulation from these agencies, it's very hard to actually understand what they want, and it's not until you start to do something that you actually figure it out. So we were now forecasting to finish that around the end of February. A bit risky, but still in time. Okay, one more sprint. Here's what happens. yeah, that was my reaction too. So the team is delivering well. We are getting work done on a steady pace, but the size of the backlog is now out of control. We now have 20 stories to do, and we are now projecting to finish well past the March deadline. Again, all legitimate work, by the way. It's not the scope creep or anything like that. Just things that we hadn't anticipated before, or things that were more complex than we had realized. But at the end of the second sprint, so it was now the end of November, we were able to raise alarm bells, immediately call our stakeholders in and say, okay, we now have a problem, we need to do something about this, we're not going to hit the deadline, what can we do? And with a bit of work, we managed to bring down the backlog a bit, but also identify in that backlog what was the very bare minimum MVP that we could implement just to make Ofcom happy to meet the regulation, and then we could take our time to implement the rest. So that's what we did. A few more sprints went by, and this is around the end of February. You see the flat line. So at this point, the team was able to deliver the MVP, and we were able to take a little bit of a break from this project to catch up with other work that had come up in the meantime. We had an MVP that wasn't great, required some manual intervention, but it was enough to meet the regulation. And in the following few sprints, we then completed the work to fully automate it and catch up with some technical debt. Now, if you were a project manager or someone that looks after the delivery of this project, you will look at this and probably scream in tears, thinking that, oh my God, this project, the size of the backlog tripled, this was a disaster. But having lived through this project, I can tell you it was quite possibly the most agile project I've ever done, because at any point in time we were in communication with our stakeholders, showing them what we were doing, when things were expected to get done, and we were able to react immediately when we were starting to be off track. If you like anything that I talked about and you would like to try this with your teams, my advice is actually to keep doing what you're doing, keep doing your estimates, story points, whatever you're doing now, but on the side, start collecting some data. And the next time that you need to estimate something, also use some of these spreadsheets or some of the tools I showed you to run a forecast. And then as the project unfolds, you keep updating your forecast, and at the end, compare the results. What did your estimate say? What did your forecast say? And compare and discuss. And usually showing this to your team will generate, at the minimum, some interesting discussions, and often it's enough to convince them that you can rely more on data instead of your estimates. To recap, what I shared with you today is that when we're dealing with uncertain events like earthquakes or software projects, a forecast will almost always beat an estimate. But we need to become really good at communicating our forecasts to make people listen to us. Thank you. I think we have a couple of minutes for some questions. Yeah. Hey.
How do you deal in situations where you have little historical data, like new teams, or when you have variability, team composition changes, do you factor some new numbers there, or you just communicate better with the stakeholders?
Yep. I'll repeat the question for the recording. The question is, what do you do when you have little data, or maybe the previous historical data is unreliable because things changed too much? What I do, I tackle this in a few ways. One is, well, if the team was already together and had some data, I run a few forecasts with a few different data sets using data that will give me some information. So I run a forecast with the actual past data, even if I think that it's not reliable. I run a forecast with data from other teams in the company to give me an idea of how things operate in the company. I ask the team what they expect their throughput might look like and run this ideal forecast. Put this together with asking them what they think, how they feel, and gives us an initial feel for how long things are going to take. But then as soon as we actually start working on the project, I replace this ideal data with actual data. Yep.
You had sort of your sort of optimistic and sort of pessimistic sort of completion rate.
Yep.
It also seems obviously you saw the backlog grow continuously, which
Yep.
it genuinely does. Is it worth kind of having a sort of an optimistic and pessimistic kind of line that follows that as well? What do you think it might get to?
Yeah, you totally should. That was let's say maybe a simplified version. Yeah, assuming that the backlog. In that particular example, I wasn't doing that, but because it's quite difficult to do that in a spreadsheet, to be honest. But those tools actually do that, and it's definitely something that should be taken into account. Yep.
Quick one. So the forecast you showed was based on number of stories, i.e. throughput.
Yep.
Do you think it'd be better to do it based on effort, because that will factor in complexity as well, or was there an assumption that the throughput assumed that all the stories were of medium or low complexity?
So when you say effort, I guess you mean something like.
Effort is the time it takes to do it. Say complexity plus risk. Story points, maybe.
Well, you can try and use that as well and see if it gives you any extra information. But what I expect is that, like in most teams, there will be actual low correlation between that estimated effort and how long the piece of work takes. So usually I don't take effort into account or story points into account because the team will have gotten good at slicing work down into small vertical deliverables. But just to be clear, they don't all need to be the same size. That's a bit of a myth. So long as you make them as small as you can, there will be some natural variation in size of the work. And that's the variation that you see represented in the lead time distribution. Some things still take a few more days than others. But that variation is not due to the size of the work. It's more about how much work in progress you got, what else was happening in the team. That's what really adds variability, not the size of the work. I'm going to pack up now to give the next speaker time to set up, but come and talk to me anytime. I've got a couple of copies of the book to give away if you want one. Thank you.